Alright everyone, Cody here. Welcome back to my lab. So, behind me, you can see some of my algae experiments going on. I am super excited about this and I just couldn't wait. I want to talk to you guys about this a little bit. So, ultimately this is for Chickenhole base. That project, I've always assumed that I would use some algae because it is fairly compact and energy efficient. It is more efficient at converting sunlight into usable food than most other plants are because it doesn't have to use a bunch of energy standing up, basically. It's just floating there. It's not having to pump water and nutrients around. It's just sitting there converting the sunlight into energy. It's super efficient. And it doesn't take up much space. You can just pump it through tubes or whatever, and it doesn't take very much volume. I don't need big greenhouses to grow it. Just tubes, really. Doing some research, apparently you can feed about 25% of a chicken's diet replaced with algae to the chicken, and the productivity of the chicken will not decrease. So, yeah, it's more efficient to grow, so I don't have to grow as much wheat, essentially, to feed my chickens. So I was doing some research, just watching YouTube videos, learning how to grow algae, because I figured it'd be something that's nice to know. And I saw one video, I'll link it below if I can find it again. A guy is growing some spirulina, which I actually have right here. He was growing spirulina algae, which is actually a type of cyanobacteria. It's an extremophile, in a pond in his backyard, and it's growing in alkali water. He added sodium bicarbonate, baking soda, to the water to make it alkali. And he's talking about it, and he mentions that the water becomes more alkali the longer the algae goes on. Because the algae is consuming the bicarbonate, releasing oxygen and taking that carbon and incorporating into its biomass and leaving behind the carbonate. So it's converting bicarbonate into carbonate. And that just lit up a bulb in my mind, because he's saying it's going from a pH of 8 to a pH of 11. So pH 8, that's roughly 16 grams of bicarbonate, sodium bicarbonate per liter. pH 11 is about 10 grams of sodium carbonate per liter. And that is exactly what happens if you take the extra CO2 in the bicarbonate and remove it. It's like, to make bicarbonate, what you do is you bubble CO2 into the solution of sodium carbonate and partially acidify it to make the bicarbonate. I hope you guys are following along here. So, pure water absorbs CO2 from the air, okay? If you have 100% CO2 over the water, you can absorb at 25 degrees Celsius about 1 gram per liter. But according to Henry's law, as you decrease the concentration of CO2, the concentration of dissolved CO2 also decreases. So if you drop it from 1,000,000 parts per million to 1,000 parts per million, you also dissolve about 1,000th as much CO2. So you go from about 1 gram per liter to 1 milligram per liter, which is tiny. The tiny amounts of contaminants in the water, like calcium carbonate, is actually going to react and consume more CO2 than pure water would hold. But with this, we've got 10 grams of sodium carbonate per liter to react with the CO2. It can hold 6 grams of CO2 per liter, and it doesn't matter what the partial pressure of CO2 is. It's chemically reacting with it. It is pulling it down. The sodium carbonate, you've all probably put baking soda in water, it doesn't just immediately start fizzing and bubbling and releasing CO2. It's perfectly happy sitting there with just 1,000 parts per million of CO2 above it. So, to absorb all of this CO2 that I breathe out in a day, for the chlorella, it lives in neutral water. It would need thousands of liters of water living in, and it would only consume that CO2 during the day. It might consume, that amount would absorb about a gram of CO2, and then the algae would consume it and use it in a few minutes, and then another gram would come in. But that's only when the sun's shining. When the sun's not shining, it would actually release CO2. The spirulina, though, it's living in alkaline water. Water that's so alkali that you can absorb the entire amount that I breathe out in just 25 gallons. And it would do that even in the dark, even at night. So if something happens in the base, say mushrooms decide to all start producing all at once, or I don't know, the compost tumbler, the bacteria decide to really kick off and produce a whole bunch of CO2 at once. Well, there's a reason why I assumed that I would have the base segmented into different sections, where things that could do that would be isolated from the rest of the system. But the spirulina would be able to use up that CO2. If I had 1,000 gallons of spirulina in its alkali medium, it would just take that CO2 spike and just absorb it. And then later, perhaps over a week, it could just use the sunlight to regenerate the alkali. I've always assumed that I would use alkali solutions such as lime as an emergency CO2 scrubbing system to pull CO2 out of the air, like if it's been cloudy for a week and the plants and my crops haven't been producing a lot of oxygen. Well, it's not really the oxygen that's the problem, it's the CO2. The CO2 gets above 10,000 parts per million and it starts causing major problems for me. So you'd want something to pull it down in an emergency to scrub it out of the atmosphere. Ultimately, with Chickenhole base, I would, the last resort would be to open the windows, essentially. But, on a Mars base, you wouldn't want to lose all your atmosphere, so you have alkali solutions to pull it down. And then you'd later, when you're producing oxygen again, using the CO2, you could put the alkali solution in a furnace or something and bake the CO2 out. The spirulina, though, it just needs a bit of light, and it can regenerate the solution. Anyway, hopefully you guys understood that rambling mess. Until I'm excited. Hope you enjoyed. See you next time.